So these are the six trig integrals that we're going to learn today. And the first couple, sine and cosine, what we need to think of is what function has sine as its derivative. What function has sine as its derivative? Cosine does, and it would be negative because the derivative of cosine is normally negative sine. So to make it positive, we got to do negative. So we have the antiderivative of sine is negative cosine x plus c.
Ooh.
What is the antiderivative of cosine?
Sine.
Sine.
Plus
Very
c.
good.
Gotta remember c.
What function has a derivative of secant squared?
Tangent.
Tangent.
That would another.
Should we negative tangent?
Is the derivative of tangent negative secant squared, or is it
No.
positive?
Positive.
Oh, good, squared. See, no.
No, only the C ones.
Number
have
4 is
negative.
negative cotangent x.
Only the C ones have the negative.
Yeah, it's
Oh,
positive.
okay.
It's positive. Derivative of tangent is just secant squared.
It has to be
However,
Norman.
what function has a derivative of cosecant squared?
Negative cotangent.
Negative cotangent. Okay, what about secant tangent?
Secant x plus c.
X plus c.
You got a smart guy here.
And cosecant cotangent?
Negative cosecant x.
Negative cosecant x plus c. Now,
Another is just on the roll.
the ones that get messed up the most without question are sine and cosine. Because what happens is the derivative of sine is cosine, the derivative of cosine is negative sine, the integral of sine is negative cosine, the integral of cosine is sine, and people get the minuses confused, right? So, and most of these are multiple choice questions. And if you're negative, if you're off by a negative, you're off, right? You're wrong, you're wrong. So the problem with these is sine and cosine. Please be very careful to keep them straight. That the derivative of sine is cosine, but the antiderivative of sine is negative cosine. So be very careful about that. One of the things that helps me, when you're doing a derivative, if the function starts with a c, the answer is negative. When you're doing an integral, if the answer starts with a c, it's negative. And that's because the answer would have been the original function when you were doing the derivative, right? So when you're doing an integral, if the answer starts with a c, it's negative. Does that make sense? Okay. All right, so those are the 6 trig integrals. Now, obviously, we're not going to just sit there and say, hey, what's the integral of secant tangent? So we've got to add a little spice to it. So for our first example, we're going to see if we can find the integral of 1 plus cotangent squared.
Okay.
Now you're looking at 1 plus cotangent squared and you're thinking, you're looking through your list of 6 and that's not up there.
Oh, you can convert this one.
What do we do?
You
Identities.
break down
Oh,
cotangent squared.
Hey, isn't it helpful that we have all these beautiful trig identities to choose from?
1 plus cosecant.
Close.
Cosecant.
You're somewhere in there. Okay, it is a Pythagorean identity that we need to use.
Oh, but the one's over there. Okay, so it'd be just cosecant. Wait,
Let's see.
No.
Let's see.
Don't rush up.
I know sine squared plus cosine squared equals 1. Right? That's the only Pythagorean identity I know. So how do I figure out which one would have a cotangent in it?
Divide by cosine.
You divide by sine.
Sine
Sine squared x.
Divide by something.
Yes.
Divide by sine
Let's
Sine
divide by
squared.
sine squared.
Divide
So
by
if we
math.
divide by sine squared, that's how we're going to get the cotangent. So if we divide everything by sine squared, we get 1 plus cotangent squared equals cosecant squared, which means we can just replace this integral with the integral of cosecant squared.
That's convenient.
It is convenient, and wow, it's helpful that we know that answer. So what is the answer? What function has a derivative of cosecant squared?
Negative
Just cosecant squared. You would take the integral of cosecant squared,
And what would you get?
and I would get negative cotangent x plus c. 'cause
Negative
that's
cotangent x plus c. Make sure you know those, because they will show up tomorrow on your quiz. Ready? Okay, one more. I want you guys to try this one in your groups.
I think my dragon. Does this one involve math?
Yes, it involves math.
So many
Is
letters.
there gonna be multiple choice in the
Where are the
group?
numbers in this price? I
No,
thought this
the higher you go in math, the less numbers there are.
Really?
Yeah, really.
That's tragic.
The quiz tomorrow is just 5 problems, 4 points each. It's
It's
a
like they're
small
going
quiz.
extinct. We should fight for the numbers.
So we have the integral of sine over cosine squared. See if you can manipulate that somehow.
Okay. So
So
cosine squared
negative
is sine,
Cosine, like,
or no, it's
cosine
like
squared
tangent divided
is
by.
negative 1.
I can do this.
Yeah, that sounds right.
No, bro, what's tangent isn't sine of cosine? Cosine of sine.
So sine x times cosine negative 2.
Let's get it squared though.
Raise the negative 2.
Yeah, so you'll have sine over cosine, and then whatever, sine over cosine.
So then, what would that be?
And then you just look up top.
What's sine over cosine?
Wait, how would you do that, Jacob?
You guys did it together.
I love making notes, that's going.
What's the one over cosine? Cotangent.
But it's so hard.
Anyone need another minute?
Yes.
Yes, Jacob has.
Jacob was working all by himself. He didn't even try to help us.
I was kinda like, we gonna go over them next.
Jacob, you know, I thought this was a teamwork.
Do I keep explaining?
Yes, please. That's right, stop hovering over us. You're trying to you're making
Makes
it
it
awkward.
It makes it awkward, it really does. Alright, so basically, cosine squared is cosine. You got it.
Cosine squared is cosine times cosine, so sine over cosine is tangent, right?
Yeah, and then you still work off with one cosine.
Right.
It's 1 over cosine.
Yeah.
I had a dream last night about calculus.
You had a dream about calculus?
It was like, you got tired of carrying your laptop around.
So, you can't just have cosine. You would have.
My one laptop, I made you guys split it up amongst the 35 of you as a class computer.
I
Alright.
had a dream that came out with the Lion King 4.
You had a dream that Lion King 4? Is
It was
there
a
a
good
Lion
dream.
King 3?
It's like
RGX, right?
Okay.
30 feet away and like secant square
Why not?
What I had
Alright, good. Quiet down, please.
number 5.
So, be aware of those identities when you're working these problems. If you don't recognize the function as one of the 6 right here, see if you can manipulate it to look like one of the 6. 1 over cosine is the same thing as secant, and sine over cosine is the same thing as? Hey, so this is just the integral of secant tangent, which is
That one.
secant x plus c, right? Okay, it's time to move on to our next topic, which is actually a heavy-duty calculus college topic.
Ew.
There are whole college classes devoted to just this.
Different. Why am I not eating my lunch?
Differential equations.
That's weird.
You have to grab today.
I don't know. I have
Now, a differential equation is just an equation with a differential in it. That's all it is. I know. Whoa. So all it is an equation that has a derivative somewhere in it. Now, if, for example, suppose I said, hey guys, y prime equals 2, find y. So, but there's a trick, not a trick, but there's a method that I want you to follow. Most of you, if I told you y prime is 2, what's y? Could you tell me what y is? Give me an equation for y. 2x plus c. 2x plus c, right? Okay, so most of you just jump right to the answer. I am going to make you walk through a process that's going to feel long and convoluted and unnecessary and slightly annoying. And the reason I'm gonna do this is because today we're just doing little infant baby differential equations. And we're gonna slowly work our way up to like maybe elementary school differential equations. Yes. When we get to the elementary school differential equations, if you don't follow this method, you're gonna get really in trouble. So I'd like us to just go ahead and build a solid foundation and do them correctly right from the start. So here's how I want you to approach these problems. We are never going to use y prime. We're going to write y prime as dy dx.
Or are we gonna like divide out the dx?
We are. We're going to multiply both sides by dx. Remember, dy dx is a fraction. So we're going to multiply both sides by dx, and we have dy equals 2 dx.
Are we gonna divide by the d?
No.
Can you divide by the d? No. Okay, it's a good try. No, instead what we're going to do now is integrate both sides.
Dummy.
So you just draw an integral on both sides. Does anyone know what the integral of just dy is? Y, because there's an invisible 1 there, right? The antiderivative of 1 with respect to y would be y. Okay, no plus c on this side, just put the y. What's the antiderivative of 2 dx?
2x plus c.
2x, and now we put the plus c. Now, the reason you only put 1 plus c for the entire equation is because you only need 1 plus c for the entire equation. And if, say for example, it was y plus 3 equals x, 2x minus 4, you can always move this constant over and lump them all together, right? So you only need 1 plus c to represent all the constants for the equation, and that's all you should want. So don't put a plus c on both sides, and always put it on the independent variable side.
So it'd be like saying 2 times infinity. If you put an extra c in, like what would make no difference?
If you put an extra c in, oh, I see what you're saying, that you don't need a 2 times infinity because it's still infinity. If you put a c, no, if you put c here, what you're saying is you have to split the constant into 2 equal parts, and then that just gets kind of confusing. So, yeah, just put 1 c and put it on the x side. Okay, so all of you, take a second and try this one. So solve for y if, I'm going to just start you off with dy dx equals x cubed.
Oh, I did 4.
Yeah.
Alright, so what should we do first for this one?
Multiply dx.
Multiply by dx. So we're going to move that dx to the other side,
Take the integral.
put an integral symbol on both sides. What's the integral of dy?
Y.
Y. What's the integral of x cubed?
X to the 4th divided by 4.
Sure, 1/4 x to the 4th plus c. Done. Okay? Alright, let's do another type. There are 2 types of differential solutions to differential equations. There are general solutions, and there are particular or specific solutions. Some call them particular solutions, some call them specific solutions. So we're going to find both for the following problem.
That's right.
Yes.
You know how when you like take the integral of like y or dy becomes y?
Yes.
And when you're taking the integral of dx, is that why the exponent goes up? Because then it's just like x to the 3 times like just x, or no?
Not exactly. The dx is that width of the rectangle, So it's not part of the operation of finding the integral, it represents that rectangle width. This is the height of your rectangle, and when you take, this is really the operator that's telling you raise the power by 1, divide by the power, which is really just a shortcut method for doing that whole limit definition that we learned. And really for this, you have to, you can, remember we were talking about like the power rule for derivatives, the way to prove it is with mathematical induction. That's how you prove it. So it's not really like this is the x you're multiplying it by, but it is another dimension that you're at, that you are multiplying by. So I guess in that way, you could think of it that way. I don't know. Anyway, alright, back to example. Alright, suppose, make sure I use the right numbers, so I don't work out decent. So, suppose y prime equals 3x minus 4. Find the general solution for y. Then find the specific solution if the point 4, 10 is on the graph
Ooh, that's long.
of y. Alright, so first we have y prime equals 3x minus 4. First thing we gotta do is find the general solution, then the specific solution using that point. What I want you guys to do is take a minute and everyone just find the general solution first, which is just what we've been doing.
Oh, yeah. I always forget that.
Okay. What's the first thing you did? Right, changed your y prime to a dy dx. Then what? Right, move the dx to the other side, so dy equals 3x minus 4 dx. Make sure you put the 3x minus 4 in parentheses, because it's the entire quantity times dx. Now what? Integrate both sides, so what's the integral of dy?
Why?
What's the integral of 3x minus 4?
3 halves x squared
3 halves x squared
minus 4x.
minus 4x plus c. This right here, that's your general solution. Right, so the solution with the plus c, that's the general solution. Now if you need the specific solution, the particular solution that passes through the point 4, 10, well, this is a point on the graph, so we can plug the 4 in for x and the 10 in for y and just solve for c. So, whoop, yes?
No.
Oh, just excited about it? Yay! Okay, so 10 equals 3 halves times 4 squared minus 4 times 4 plus c. So, we get 3 halves of 16, so that would be 24 minus 16 plus c. So 10 equals 8 plus c, and c is 2. So our specific or particular solution would be y equals 3 halves x squared minus 4x plus 2. that make sense? So you're just given a little bit more information so that you can solve for C.
Your children watch like the old time cartoons,
Sometimes.
Do they need
Bugs Bunny.
You know, we love the new Bugs Bunny, the Looney Tunes shows.
Oh, like the baby one.
No, where they live like on the cul-de-sac.
Oh,
that one.
That one's pretty good.
They live on the
We
island.
love those. They're so fun.
What about like superheroes, like the Justice League?
No.
Yeah, they love those.
I watched the entire 2001 series in like 2 days.
Wow.
It was
I like-
23 hours. It
I
was
like
2
the
seasons of 23 episodes each. It was pretty intense.
Alright, the next type of problem we're gonna do is similar to that but different, and I don't want you to spend the time walking through the steps that I've shown you. It's a related but a different type of problem. So here we go. These are kind of fun. I think they're fun. Suppose f double prime of x equals 6x plus 4. F prime of 0 equals 3. And f of 1 equals 5. Find f of x. This is like a mystery, right?
This is like the last one.
Okay. It's similar. It's similar. But you don't have to sit there and do all the dy dx stuff because you'd have to do the d squared y dx squared and that'd be confusing. So just
You
do
just take the integral
F.
of
f prime and f. All right. There we go. The whole thing. Yeah. All right. So this is f double prime. So the first thing you have to find is f prime, right? So we got to have kind of step backwards into it. Everyone take a second and write f prime. All right, now, once you get f prime, what is f prime?
6 over 2.
What is 6 over 2?
Oh, 3.
Plus c. So, is there any information that we can use to solve for c?
Yeah. 0 and 3.
F prime of 0 equals 3. Go ahead and plug in the 0 and set it equal to 3 and see what you get for c. So what is c?
3.
It's 3, right? Because f prime of 0 would equal 0 plus c, and it's 3. So c is 3. So our new f prime, 3x squared plus 4x plus 3. Was there a question? No? Does everyone understand that? Good. Go ahead and find f. Oh, a little trick though. I'm actually going to walk you through this. When we find f, so you guys tell me, walk me through, what's the first term?
X cubed.
X cubed
2x
plus 2x squared
plus 3x.
plus 3x.
Plus
Okay,
Plus
now
c.
here's the thing. C in this problem has already been decided to be 3, and we don't know that the unknown constant here is 3, so we can't call it c. You have a choice. Some students like to say call this c sub 1 and this c sub 2, right? And if you have like 10 of these to do, that's the best way to go, right? Just subscripts. If you just have a couple, personally, what I like to do is I just call my first constant c and my second constant k.
You should have made it A.
Oh, I use k. It's just habit. But you can use a. Nothing wrong with a. Just as long as it's not the same as the first constant.
So you'll accept either way on quiz or test?
I'm sorry.
Will you accept either way on a quiz or
Like
test?
with the subscripts? Yeah, as long as there's a way to differentiate
Can
between
we put a smiley face?
I would prefer
It
letters.
doesn't have to be like.
And we stopped there, right?
Can you be like,
I'm
No,
sorry?
we have to check. We have to find out K.
Now you gotta find k.
But just as fine f of x though.
Yeah,
Yeah, but I want the actual function with no unknowns.
So F.
There you go. So we know that f of 1 is 5, so plug in your 1. So you get 1 plus 2 plus 3
Into a
plus
site
k
ignorance.
equals 5.
5 bottom.
So it's k, -1. So now our f of
I
x,
look like a better gayer.
x cubed plus 2x squared plus 3x
Better.
minus 1. I always like these.
Yeah, for sure.
They're kind of fun.
I mean,
Now, we gotta take it up a small notch.
I don't know if we have enough time for a notch.
I think we do.
Price, you're looking at the clock right now.
Who will win this, Price or the clock?
11:17.
Dun 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 dun.
All right, we'll see.
Dun, dun, dun.
My second page. Oh, I'm already costing myself time.
See, this is why you got an award-winning quarterback.
All right, suppose g double prime is 12x plus 6, g of 0 is 4, and g of 1 is -2. And now you have to find g. I'm going to walk you through this for time's sake. Everyone got a copy down?
No.
Okay.
So students will be the end of you. Strategically slow students.
Okay, so antiderivative of g double prime would be 6x squared plus 6x plus c. Do I know any other information about g prime? Nope, so I can't do anything. Gotta go on to g. So g, well, let's see, this would be 2x cubed plus 3x squared. What's the antiderivative of c? Cx, because c is a constant. The antiderivative constant is the constant times x, and I still have to put an unknown constant for this guy. Do you all understand? Antiderivative of c is not 0, it's cx. Then you gotta still add a plus k. Alright, now let's plug in what we know.
Oh, we're gonna have to accept the, or like, the addition type thing.
Nah,
What are we trying to-
since
what
I
are we
give you
trying
g
to
of,
find? What are we trying to find?
g of x, the original function.
Okay.
So since I plug in a 0, I get k equals 4, which is nice. So I'm just gonna rewrite with my k. Cx plus 4. And now I plug in a 1, I get 2 plus 3 plus c plus 4 equals -2, 5, 9, c is -11, and my final function is 2x cubed plus 3x squared minus 11x plus 4. Ha ha. Price wins.
If you didn't give us one that had like 0 that just like can't.
Then you'd have a system of equations.
Ew.
Yeah.
I bet that's gonna be on the test.
Oh, I don't know. Okay, so quiz
Very
tomorrow
tough.
is short and simple. It's just 5 problems and it's only over